Continuing now with class number 4, here's example 2.5. Determine the pressure for water at 200 degrees Celsius with a specific volume of 0.4 cubic meters per kilogram. We're getting pretty good at this so far, I think. Let's check it out. So let's go to, because I have it tabbed, and go to this really quick, and we could say we have a temperature of 200 degrees, right? So the temperature for 200 degrees, I believe, is on the next page at the top. And so we check it out. At 200 degrees, we have a vapor pressure. A specific volume of point, where do you go? 0.12736, right? But we're looking for 0.4. So our specific volume is larger than this. Therefore, we must be a superheated. You could think of the specific volume as being the inverse of density, and something that is a very low density is probably more likely to be steam, right? So, so a large number here is the same deal, just upside down, right? The other way around. That's the way I think of it. So we know that we are superheated, so we go to the superheated tables instead, and we start going on the hunt for 200 degrees and to see what the specific volume is, right? So that one doesn't work at 10 kPa. We can even come down to here and take a look, and we're still nowhere close, right? Because we're looking for 0.4. So we have to get to a smaller number. Let's go over to the next page. Take a look at some of these. We go to 200. Well, we don't even have 200 degrees, do we? I'm trying to think of, do we need to go backwards? We have, we don't. Here we go. Down here we do 200 degrees, right? And in between there, we got 0.42 and 0.35. Look at that. So it's somewhere between 500 and 600, right there, in order to be at 200 degrees. So we need to write these down and get an interpolation table going. So let's document these things that we just did. First, we went to table B.1.1, and at 200 degrees, I like to write the T in there. At the T equal 200 degrees Celsius, which, just for the record, is a PSAT of 1,553.8 kilopascals absolute. We found that the VG is going to be 0.12736 meters cubed per kilogram, and this is going to be less than 0.4 meters cubed per kilogram. Therefore, superheated. And so then we go over to table 8.1.3. And we look around at the temperature of 200 degrees, and we find that we are right there in the section between 500 and 600 psia. So that's the place we're going to look. So we look at the value here of 0.42492, and 0.4 is what we want to try to get, and the one that corresponds to 600 is 0.35202. And we set about doing our interpolation tables here, where we go compare these two, divide it by the comparison of these two, compare these two, and divide it by the comparison of these two. And as long as you're consistent, you should be able to get it. So 0.42492 minus 0.4 divided by 0.42492. And my 4s and my 9s look a little bit too much like each other. I gotta do that a little bit better. Minus 0.35202. But I'm kind of tired. Had a long day. It's going to be even longer, though, so I got to get used to it. I got to go grading some things. 500 minus 600. And sure enough, you'll get the P, and you'll find out it's 534.2 kilopascals. Absolute is the pressure that we would get for that example. All right, so I'll do some more examples in the next video. This is the last one from Borgnacki, and I want to know how to pronounce his name. Somebody needs to come up with an explanation how his name is pronounced. If Mr. Borgnacki, Dr. Borgnacki probably is listening, please send me an email with your how to pronounce your name. But I'm getting loopy, and I'm going to go on to the next example. See you soon.